Right now, in the middle of the North Sea, Denmark is flirting with an idea that sounds less like a government infrastructure plan and more like something pulled straight off a science fiction map, an energy island. And no, this isn't a metaphor. It's not a branding slogan. It's not a political buzzword. It's a real physical offshore hub built far from land, designed to collect electricity from multiple offshore wind farms and push that power outward through massive subsea cables, feeding Denmark and neighboring countries, as if the North Sea itself had become both a shared power plant and a major junction in Europe's electrical grid. Inside the energy sector, this vision has a name, Vindø, the North Sea Energy Island. And at its core, the promise is surprisingly simple. Go where the wind is best. Roughly 60 miles offshore, the air behaves differently. The wind is stronger, more consistent, less disrupted by terrain buildings and land-based turbulence. Out there, offshore wind turbines spin more steadily. And when you're talking about systems measured in multiple gigawatts, consistency isn't a detail. It's the difference between a cool project and the backbone of an energy system. Public descriptions of Denmark's hub almost always land on the same scale, around 3 gigawatts in its first phase, with the potential to grow toward 10 gigawatts over time. That's not a large wind farm. That's a small country attempting to build an offshore node powerful enough to supply millions of homes and still export electricity across national borders. But here's why this story becomes addictive. Because the impossible part isn't generating the electricity. Denmark already knows how to do offshore wind. The impossible part is building the middle. A port in open water. Offshore converters. Maintenance facilities that can survive North Sea storms. A platform or an artificial island stable enough to carry heavy grid equipment for decades while salt waves and corrosion constantly try to tear it apart. And then comes the plot twist that turns this into a modern mega project thriller. The price tag and the timeline refuse to sit still. Some reports have placed the investment at over 200 billion Danish kroner, roughly 30 billion US dollars, with completion dates slipping toward 2036 or later as construction costs and interest rates surged. Other analyses floated even higher numbers. So today, we're going inside Denmark's energy island idea, what it actually is, why Europe wants it, how anyone would even attempt to build something like this in the North Sea, and why the hardest battle may not be against the ocean at all. It might be against economics, politics, and the power grid itself. Because building a hub is one thing. Convincing multiple countries to route their energy future through it, that's the real suspense. If you ask why Denmark would attempt an offshore hub instead of simply connecting each wind farm directly to shore, the answer starts with a problem the entire European energy system is now running into. Offshore wind has gotten too big to behave like a project. Once you reach multi-gigawatt scale, you stop thinking in terms of a single cable and a single landing point. You start thinking like a grid operator. Bottlenecks, redundancy, load balancing, and the inconvenient truth that weather doesn't respect national borders. The traditional model is straightforward. Build a wind farm, run export cables to one country, land them at a coastal substation, inject power into that national grid. It works until you build too many wind farms. Then the problems stack up fast. Cable landings pile along the coast, permitting turns into a political knife fight. Transformer capacity hits its limit. Specific transmission corridors get overloaded. And worst of all, you create isolated islands of generation that don't talk to each other very well. Now zoom out to the North Sea. It's one of the best offshore wind resources on Earth. Denmark, Germany, the Netherlands, Belgium, the UK, Norway. Everyone is racing to build there. The wind potential is enormous, but the grid challenge is just as large. How do you move that much electricity to where it's needed when it's needed without turning the entire coastline into a permanent cable construction zone? Denmark's answer is hub and spoke. Instead of every wind farm running its own separate line to shore, multiple farms connect to a shared offshore hub. At the hub, the power is gathered, converted, and then sent through fewer but much more powerful links to multiple countries. In Denmark's vision, energy islands become part of a smart North Sea grid where renewable power is shared and balanced across regions instead of trapped inside national silos. That's why location matters. Consortium descriptions place the hub far offshore again, about 60 miles from land, because that puts it closer to multiple wind zones at once, while tapping into stronger, steadier winds. So the energy island isn't just a place to stand, it's a strategy. Collect power where the wind is best. Convert it into a form the grid can move efficiently. Send it to multiple coastlines. And let countries share variability. When one side has excess, another absorbs it. In theory, this improves energy security too. If one cable fails, others can still carry part of the load. If one country is short, interconnections help. And as Europe electrifies heating, transportation, and industry, that flexibility becomes priceless. But the moment engineers translate this vision from a slide deck into steel and concrete reality, hits hard. A hub isn't an arrow on a map. It's steel, concrete, subsea cables, converters, cranes, ships, crews, weather windows, and 20 to 30 years of maintenance in one of the harshest offshore environments on the planet. And that's where the debate that sounds boring but decides everything shows up. Do you build a real artificial island, or do you build something closer to a cluster of massive offshore platforms? Because the North Sea doesn't care what you call it. It only cares whether it survives. In the public imagination, an energy island means one thing: a patch of land in the sea, something you can walk on, buildings, a dock, lights glowing at night. But in engineering terms, that's only one option, and possibly the most dramatic one. Project materials describe the North Sea island as a flexible concept, a reclaimed sand island, modular offshore platforms, or hybrid solutions combining both. Industry presentations often talk about a fixed, reclaimed base with add-on modules, allowing the design to evolve as technology and markets change. Why the ambiguity? Because creating land in the North Sea is a completely different challenge than building land inside a protected bay. Here the enemies are constant waves that rarely stop, storms that erase schedules, salt water that eats metal, and seabed conditions that vary wildly by location. If you go the reclaimed island route, you need a perimeter, a breakwater, and seawall strong enough to take decades of punishment. Inside that ring, you fill with sand and rock until the surface sits safely above sea level, even during storm surges. Then, you stabilize everything so heavy equipment doesn't settle or shift over time. But a reclaimed island is also a promised permanence. And permanence offshore is expensive. Every extra foot of protection multiplies cost. Platforms avoid some of that pain. Instead of creating land, you build massive offshore structures similar to oil and gas platforms, but designed for electrical equipment. You modularize, assemble, import, tow them out, and install them offshore. That can sidestep certain land reclamation risks, but platforms bring their own problems: limited space, more complex maintenance logistics, total exposure to weather. You need safe year-round access, helipads, crew quarters, spare parts, storage, repair capability. You're not just building infrastructure, you're building a permanent offshore workplace. And that workplace has to function when conditions are terrible, because the power grid doesn't politely close for maintenance. That's when the energy island starts to look less like a power plant and more like a compact industrial city, harbor facilities for service vessels, operations buildings, parts, storage, control rooms, and at the center of it all, the equipment that turns wind farms into an international energy highway, the converter station. Wind turbines generate electricity as alternating current, but long-distance subsea transmission at multi-gigawatt scale often pushes you toward high-voltage direct current, or HVDC, because it's more efficient and more controllable over long distances. A hub feeding multiple countries needs conversion and control offshore, not just on land. In other words, the island doesn't exist mainly because of turbines. It exists because of converters, switchgear, and interconnections, heavy, sensitive, and extremely expensive grid infrastructure. And this is where the story tightens. Because once you decide to put HVDC converters offshore, you're also committing to something else: maintaining one of Europe's most complex electrical systems in the middle of the North Sea. So how do you do that? How do you fix equipment in winter, not just summer? How do you replace a transformer the size of a house while waves rock the service vessel? That's the hidden challenge at the heart of Denmark's dream. And it's why this project isn't just about renewables. It's about reinventing offshore operations at grid scale. To understand what Denmark is really trying to build, imagine a classic offshore wind farm. You have turbines. You have an offshore substation collecting power. You have export cables running to shore. Now scale that up until the substation becomes an international junction box. That's the energy island. At full ambition, the North Sea hub gathers several gigawatts, starting around 3 gigawatts, potentially growing toward 10 gigawatts, and then splits that power across multiple high-capacity links to different countries. Why does that matter? Because power grids aren't designed for perfection. They're designed for control. Wind fluctuates. Demand fluctuates. Every country has different peak hours and generation mixes. When you interconnect at scale, you smooth the bumps. You export excess when one side is windy. You import when another side is calm. That's why Denmark insists energy islands are cross-border infrastructure, not just national assets. And it's why hub and spoke shows up so often in official language. There's a second reason grid engineers love this idea: stability. A multi-country hub improves resilience. If one line trips, others carry part of the flow. If one grid is congested, power can be rerouted. Control systems manage flows dynamically instead of relying on isolated point-to-point connections. In Europe's future, this isn't a luxury, it's survival. Electrification is accelerating. Industry wants clean power. Data centers want reliability. Heat pumps and EVs drive winter demand spikes. And Europe wants to cut dependence on imported fossil fuels. That turns the island into a strategic object, shared hardware tying countries together through renewable electricity. But strategy comes with a price complexity. A normal wind farm connection is bilateral. A hub is multilateral. Wind farms to hub. Hub to Denmark. Hub to Germany. Hub to the Netherlands. and possibly more later. Each link comes with its own rules, cost models, grid operator requirements, and political risk. You can build the island, but can you build the agreement? Denmark's experience with energy islands already shows how sensitive this is. In the Baltic Sea, the Bornholm Energy Island was framed as a shared 3-gigawatt resource connecting offshore wind to multiple grids reinforced by Denmark-Germany cooperation announcements. The North Sea hub aims for similar logic, just under much harsher offshore conditions. And once those interconnections exist, another door opens, one that turns electricity into something even more complicated than electrons' molecules. Because grids move energy, but ships and heavy industry often need fuel. That's when the energy island stops being just a grid node and starts becoming a factory platform. Even if you perfect the hub and the cables, you run into a stubborn reality. Not everything is easy to electrify. A container ship crossing the Atlantic can't plug in mid-ocean. Steel plants can't flip every process overnight. Certain chemical pathways need molecules. Hydrogen, ammonia, synthetic fuels, not just electrons. That's why energy islands are described not only as power hubs, but as enablers of power-to-X, using renewable electricity to produce green fuels for hard-to-decarbonize sectors like shipping and heavy industry. Here, the island concept starts to feel inevitable. Fuel production at scale needs space equipment and constant power. Electrolyzers, water supply and treatment, storage tanks, safety systems, export logistics. Doing this offshore could, in theory, relieve congestion on land and put production close to generation. But power-to-X amplifies every hard constraint. First, efficiency. Every conversion loses energy. Electrolysis loses some. Turning hydrogen into ammonia or e-methanol loses more. Compressing, storing, and transporting loses more again. To justify offshore power-to-X, you need extremely cheap renewable electricity and very high utilization, exactly what strong, steady offshore wind promises, and exactly what the hub wants to collect. Second, operations. Power-to-X isn't passive infrastructure like a cable. It's industrial processing. That means maintenance crews, spare parts, safety inspections, 24/7 monitoring. And it means running a chemical plant in a marine environment where corrosion never sleeps. Third, integration. If the island sends power to multiple countries, who gets priority? When onshore demand spikes, do you divert power away from fuel production? When fuel contracts demand constant output, do you reserve baseload for electrolyzers? This is where sector coupling stops being a technical term and becomes political negotiation. And yet, this is also the piece that could make the hub truly transformative. If you collect North Sea wind, distribute it across countries, and convert part of it into green fuels, you create a multi-product platform: electricity for grids, molecules for ships, balancing services for the system. It's the opposite of the old fossil model where one country extracts fuel and sells it. Here, countries share a renewable resource and share the infrastructure that makes it useful. Which brings us to the wall. Every mega project eventually hits money. Because no matter how elegant the diagram, the North Sea charges rent. For a while, the energy island story felt like a sprint build. By 2030, led the world create the first offshore hub. Then reality arrived in the form of interest rates, supply chain bottlenecks, and the brutal cost of building anything in the North Sea. Public reporting described projected investment climbing past $30 billion, with timelines slipping toward 2036, or later, driven by higher construction costs and more expensive financing. That volatility isn't a mistake. It's the nature of mega infrastructure. The design isn't locked. Denmark explored multiple concepts, reclaimed island modular platforms, hybrids. Each choice reshapes cost-risk construction methods and financing. Then comes governance. Official descriptions are clear. This is critical infrastructure involving public actors, private investors, and cross-border transmission partners. This isn't build it and sell power. It's management. The Vindo Consortium itself stated that the Danish government postponed the decision to launch the North Sea hub tender opting, instead to evaluate alternative concepts and continue collaboration talks, explicitly naming Germany while pushing the timeline toward 2036 or beyond. That's the quiet truth. The island is as much a negotiation platform as an engineering one. It requires agreements on how island costs are shared, how interconnection costs are split, how the market is designed, who operates the system, and how risk is shared when something breaks offshore. If you've ever wondered why the North Sea has so much wind, but so few shared hubs, this is why. Not because it can't be built, but because agreement is hard. Zoom out one last time. Vindu, the North Sea. Energy Island is really a question turned into concrete and cable. What if the North Sea became Europe's shared power plant, instead of isolated national connections? What if countries built a junction in the middle where everyone plugs in? The plan is build a hub about 60 miles offshore, collecting wind from multiple farms, starting around 3 gigawatts and scaling toward 10 gigawatts, pushing power through high-capacity links. It's honest about what modern decarbonization demands. Not just clean generation, but efficient transmission, cross-border balancing, and fuel production. For sectors electricity can't reach alone. And it exposes the trade-offs. The shifting cost and timeline, often cited around $30 billion, and the mid-2030 highlight friction points financing supply chains and multinational governance. That's why this story is bigger than Denmark. If it works, it becomes a blueprint. If it stalls, it becomes a lesson. Either way, the wind will keep blowing. The only question is whether we build a grid that can capture it together.